Hello students, welcome back to my video classes. In the last class, we have proved a limit comparison test. In this class, we will do problems on limit comparison test. So before going to the problems, let us first recall the tests that we have. The first test is geometric series test. We know that the series summation r power n converges to 1 by 1 minus r if r lies between 0 and 1, including 0 and excluding 1, and diverges if r is greater than or equal to 1. The next series that we have is p series test. In this, the series converges. P series is summation 1 by n power p. Converges if p greater than 1 and diverges if p less than or equal to 1. The next series is, the next test is comparison test. Of course, we have not given proof for this. That's not important for us. So what is comparison test? If un is less than or equal to vn, we can omit k for our convenience. If un is less than or equal to vn and series vn is convergent, then series un is also convergent. This does not mean that if un is convergent, we can say that vn is convergent. It only says that if series Vn is convergent, then series Un is also convergent. Second point from this is, if Un is greater than or equal to Vn, and if Vn is divergent, series Vn is divergent, then we can say that series Un is also divergent. So if series Un is known to us, then we cannot predict the nature of series Vn. So from this we can only say that if series Vn is divergent, then the series Un is divergent. Next test that we have is limit comparison test. So in this test, we calculate the limit value of Un by Vn, and if it is not equal to 0, then we say that both the series converge or diverge together. So here L, the limit value should not equal to 0. What happens if limit is equal to 0? Some textbooks included that also in this theorem, but we have not included, we don't have that. So what happens if L is equal to 0? That means if limit of un by vn is equal to 0, then we write like this. Modulus of un by vn minus 0 is less than epsilon, right? So from this, if I expand, un by vn lies between minus epsilon and plus epsilon, and minus epsilon vn is less than un is less than epsilon times vn. Because this is minus epsilon, I am neglecting this, I am omitting this, because from comparison test k must be positive real number. So epsilon is a positive real number, so I am considering only these two. So from this, what we have, un is less than epsilon times vn. So here, from this inequality, we can say that if the series vn is convergent, then we can say that the series un is also convergent. So if the series vn is divergent, we cannot predict the nature of series un. So that's why we have not included the case L is equal to 0 in this test. Right? So next important point is, if summation un is convergent, then the limit of un should be 0. It must be 0. Very important. These three are very important points. If the series is convergent, then the limit of the nth term should be 0. What about its converse? If the limit of un is 0, then the series may converge or diverge. For example, if I consider the series 1 by n and 1 by n square. We know that by P series test, here P is equal to 1. So by P series test, this diverges. And by P series test, summation 1 by n square converges. But if you take the limit of both, limit of 1 by n is also equal to 0 and limit of 1 by n square is also equal to 0. So in both the cases we are getting the limit as 0, but one series is converging and one series is diverging. So we cannot predict the nature of the series if the limit of un is equal to 0. But if the series is convergent, then the limit must be 0. So and third point is, if limit of un is not equal to 0, in that case summation un is divergent. It must be divergent. So if it is 0, we cannot predict. But if it is not equal to 0, then it must diverge. So remember these points, because when you see the questions, if you are able to calculate directly the limit of un, if it is not equal to 0, then we should able to say that it is divergent directly. So here I am giving some useful formula that are used in solving the problems. We already know all of this. So limit of 1 plus 1 by n whole power n is e. It is well known to you. And if limit of 1 plus k by n whole power n is there, we take it as e power k. So whatever constant is there here, so we will write in the power of e. And we know this, if a plus b into a minus b is there, we generally write it as a square minus b square. In case, in place of a, if surds are there, like this, root a plus root b, root a minus root b, then this becomes root a square minus root b square. So this will be equal to a minus b, right? So whenever, if you see roots, square roots in the numerator, we have to rationalize it by using these factors. If root a plus root b is there, we multiply with the root a minus root b. If root a minus root b is there, we multiply with the root a plus root b, so that the resulting will no longer be a surd. Similarly, this comes from a square minus b square formula. What about this? This comes from a cube minus b cube formula, which is a minus b into a square plus ab plus b square. Here in place of a, we have a power 1 by 3, cubed root of a, and in place of b, we have cubed root of b. So this becomes a power 2 by 3 plus a power 1 by 3 into b power 1 by 3 plus b power 2 by 3. So this whole result will be a cube, sorry, a power 1 by 3 whole cube minus b power 1 by 3 whole cube. So in the resulting answer, we don't have surds. There is no root, square root or cube root. So whenever you find this in the numerator of the fraction, you have to multiply with this factor. If you find this, if you see this, you have to multiply this factor, so that if you multiply, after multiplying, the resulting answer has no surds. Similarly, this is the case with the a plus b. So now we are ready with the problems. These are the examples that we are going to do in this test. So don't panic by looking at the number of examples. All these are similar. And the questions that are red in color are a little important for us, that appear frequently in the previous examinations. So we'll start the first question. So we'll do these 7 problems in this video class and the rest in the next class. So our first problem is, So let us take this as our un for all problems. So let un is equal to 1 by 2 power n plus 3 power n. So we have to choose Vn in such a way that its nature is known to us, that is whether it is convergent or divergent, and we should able to calculate limit of un by Vn, and it should not equal to 0. So all the problems are like this only. So how we have to choose Vn, except for the first one, for the rest of all the questions, choosing Vn is quite easy. Here we'll choose Vn as, choose Vn is equal to 1 by 3 power n. And we know that this is a geometric series. Summation Vn, which is summation 1 by 3 power n, is a geometric series and is convergent. Geometric series with a common ratio r is equal to 1 by 3, it is less than 1. So that implies summation Vn is convergent. So now we have to calculate limit of un by Vn. All these problems will be very easy only if you are able to calculate limit. If it is easy for you to calculate the limit. So limit un by Vn is limit un is 1 by 2 power n plus 3 power n by 1 by 3 power n. So let me write directly, 3 power n will be in the numerator by 2 power n plus 3 power n. So if I take 3 power n common from the denominator, it gets cancelled with the numerator. Like 3 power n by 3 power n is common, so I'll get 2 by 3 whole power n plus 1. These two will get cancelled. So directly I'm writing as 1 by 2 by 3 power n plus 1. Since 2 by 3 is less than 1, so taking its power, this leads to 0. As n tends to infinity, 2 by 3 power n tends to infinity. So this will be equal to 1 by 0. This will be, as n tends to infinity, this term is going to be 0. So 0 plus 1. So this is equal to 1, which is not equal to 0. So what can we say by comparison test, by limit comparison test? So by limit comparison test, both converge or diverge together. Since summation Vn is convergent, our series summation Un is also convergent. So now let us see the second question. So very easy question. So from here onwards, we have to choose Vn as, so first what is our Un? Un is equal to 1 by 2n cube plus 1. So we have to choose Vn as the take the highest power in the numerator. What is the highest power? Let it be n power p, and that the highest power of n in the denominator as q, so n power q. So if I write both in the denominator, I'll get as 1 by n power q minus. So we will choose Vn like this. We will take Vn as, by considering highest power of n in the numerator and highest power of n in the denominator and simplifying it like this, this will be our Vn. And we can say this is convergent or divergent by p series test. Suppose here say k is there. If k is greater than 1, we say it is convergent. If k is less than or equal to 1, we say this is divergent. So by p series test we can say its nature. So we'll choose Vn like this, right? So in this problem, what will be our Vn? Take Vn is equal to, highest power in the numerator, there is no n, so we'll write it as 1. Highest power of n in the denominator is n cube. So we know that this is convergent. Summation Vn is convergent by P series test. Now calculate limit of un by Vn. Limit of un by Vn, which is equal to limit of un by Vn. Un is 1 by 2n cube plus 1 by Vn is 1 by n cube. So this n cube will go to the numerator. So this will become n cube by 2n cube plus 1. So taking n cube common, it get cancelled with the denominators n cube. So 2 plus 1 by n cube I'll get in the denominator. Since n tends to infinity, 1 by n will tends to 0. So in place of 1 by n, I can write as 0. 2 plus 0 cube, which is 0, which is equal to 1 by 2. So 1 by 2 is not equal to 0. So by limit comparison test, summation un is also convergent. So what about the third one? Let us write directly. Third one. Now this is our un. Un is equal to 1 by n into n plus 1. What will be our Vn? Take Vn is equal to highest power in the numerator, there is no n. In the denominator, highest power of n is n square. So this is convergent by P series test. So now calculate limit of un by Vn, which is 1 by n into n plus 1 by 1 by n square. So this 1 by n square will come to the numerator and becomes limit n square by n into n plus 1. So which is equal to limit of, if I take n common from the denominator, already n exists. If I take n common from this, I'll have 1 by 1 plus 1 by n with n square. N square gets cancelled. So I'll write directly as 1 by 1 plus 1 by n. So now taking n tends to infinity, we have 1 by 1 plus 0, which is 1 and is not equal to 0. So by comparison test, by limit comparison test, summation un is also convergent. So all problems are quite easy. We should able to calculate the limits. That's all. Choosing Vn is also easy. Now fourth question. Here un is, let un is equal to 2n minus 1 by n into n plus 1 into n plus 2. So what should be our Vn? Take Vn is equal to, so highest power of n in the numerator is n, and in the denominator it is, we have three factors. In each factor we have n, so all together n cube. So this implies 1 by n square will be our Vn. So take Vn is equal to 1 by n square, and then we know that summation Vn is convergent by P series test. Now what about limit of un by Vn? Limit of un by Vn is, it is 2n minus 1 by n into n plus 1 into n plus 2 by 1 by n square. So this by 1 by n square will become multiplied by n square by 1. So this can be written as n square into 2n minus 1 by n into n plus 1 into n plus 2. So taking highest powers common, in the numerator already n square is there, from this we will take n common, then this becomes n cube into If you take 2 common from 2n minus 1, this will be n into, if you take n common, this will be 2 minus 1 by n. So 2 minus 1 by n. In the denominator, we have already n. So from these two factors, we'll take n and n common. So altogether we'll have n cube. And in the first factor becomes 1 plus 1 by n. And the second factor becomes 1 plus 2 by n. So forgot to write limit. So n cube gets cancelled, and taking 1 by n as 0, this will become 2 minus 0 by 1 plus 0 into 1 plus 0, 2 times 0. So overall this is 2, not equal to 0. Therefore, by limit comparison test, both behave alike, both converges, because some series Vn is convergent, given series Un is also convergent. Given series is also convergent. The next question, fifth one. So here Un is, let Un is equal to 1 by n cube into n plus 2 by n plus 3 power n. So take Vn as the highest power of n is n power n, and in the denominator it is n cube into n power n. From this n plus 2 whole power n, the highest power of n is power n. So n power n is we are taking. Now both from the numerator and denominator this will get cancelled, and we are left with 1 by n cube. So this is our Vn. And we know that by P series test, this is convergent. Summation Vn is convergent by P series test. Now calculate limit of Un by Vn. This is equal to limit, our Un is 1 by n cube into n plus 2 by n plus 3 power n by Vn is 1 by n cube. So taking this to the numerator, we have n cube by 1. So n cube gets cancelled. We are left with the limit n plus 2 by n plus 3 power n. So taking the highest power common, which is n power n, taking n outside, we have 1 plus 2 by n in the numerator and 1 plus 3 by n in the denominator, and for all we have the power n. So I'll split the power to both the numerator and denominator. Now by looking at this, you can apply the formula. You can apply the formula. Limit of 1 plus k by n whole power n is e power k. So the numerator will become e square and the denominator will become e cube. So e square gets cancelled, that is equal to 1 by e, which is not equal to 0. Therefore, by limit comparison test, summation un is also convergent. Now questions 6 and 7 are given in the form of series. So we have to convert into summation form. So how does it look? The numerators, if you look at the numerators, 2, 3, 4. And the denominators are 1 power p, 2 power p, 3 power p, and so on. So how can you take this as the nth term? The nth term for this will be, so it starts from 1 in the numerator here, 1, 2, 2, 3. 3, 4. So I'll take as n in the denominator and n plus 1 in the numerator. So with the summation n is equal to 1 to infinity. So this series can be written like this, right? Let no assumptions directly. First, let us convert this into summation form. 2 by 1 power p plus 3 by 2 power p plus 4 by 3 power p plus and so on can be written as summation n is equal to 1 to infinity n plus 1 by n power p. So now, as usual, similar problem as we did in the previous cases. To start, let un is equal to n plus 1 by n power p. Take vn is equal to highest power in the numerator for n is n power 1. For the denominator it is n power p. Overall we can write this as 1 by n power p minus 1. If n power 1 comes to the denominator, it will become n power p minus 1. So take vn is equal to 1 by n power p minus 1. So is this convergent or divergent? Summation vn, which is summation 1 by n power p minus 1, is convergent if p minus 1 is greater than 1, that is p is greater than 2, and is divergent if p minus 1 is less than or equal to 1, that is p is less than or equal to 2. So now we will find limit of un by vn. Limit of un by vn, which is equal to limit, our un is n plus 1 by n power p and our vn is n power 1 by n power p minus p, which is n power p minus 1 by 1. So this will become limit, taking highest powers common. Here if I take out n common, I have 1 by 1 plus 1 by n, so 1 plus 1 by n, and here n power p minus 1, here n common is there, so p minus 1 plus 1, so which is n power p. It gets cancelled with the n power p in the denominator. So we have limit of 1 plus 1 by n. Since 1 by n tends to 0, as n tends to infinity, 1 by n tends to 0, this is equal to 1, which is not equal to 0. Therefore, by limit comparison test, summation un or given series is convergent if p is greater than 2, this case, and divergent if p is less than or equal to 2, this case. And the next problem is, what is our how can you write this in summation form? 1 plus 1 by 2 square plus 2 square by 3 cube plus 3 cube by 4 power 4 plus 4 power 4 by 5 power 5 plus and so on. So this can be written as, see, if you observe the numerators, we have 1 power 1, 2 power 2, 3 power 3, 4 power 4. So it starts with 1. So we'll write as 1n power n. So the numerator is n power n. And the denominator is, it starts from 2. 2 square, 3 cube, 4 power 4. So take the denominator as n plus 1. Power n plus 1. With the summation n is equal to 1 to infinity. But we have considered only these terms. So what about the first term, that cannot be included in this? So I am writing this as 1 plus. But you know that The first few terms can be omitted. Even then, the nature of the series does not change. The nature of the series does not change by omitting the first few terms of the series. So I'll consider, let us consider only this as our un and proceed. If this converges, then the whole series 1 plus also converges. If this converges to L, then the whole series converges to 1 plus L. So it does not matter if you consider 1 plus or you can omit 1 plus. So here let un is equal to n power n by n plus 1 power n plus 1. So what will be our Vn now? Choose or take Vn is equal to the highest power of n in the numerator is n power n. The highest power of n in the denominator is n power n plus 1. So writing it in the simplifying form, n power n by n power n into n, both gets cancelled. So we are left with 1 by n. So take Vn is equal to 1 by n. And we know that this is divergent by P series test. So what about the limit of un by Vn, which is equal to limit of un is n power n by n plus 1 power n plus 1 into Vn is 1 by n. So I'll have n by 1 here. So simplifying this, limit of n to the power of n and n, overall n to the power of n plus 1. And in the denominator, taking n outside or n common, we have n to the power of n plus 1. And what is left here? 1 is left, and in place of 1, 1 by n is left, n to the power of n plus 1. Both these two gets cancelled, and we are left with the limit 1 by 1 plus 1 by n whole to the power of n plus 1. So we know that limit 1 plus 1 by n whole power n is e, but in the power we have n plus 1. So we'll split this limit 1 by 1 plus 1 by n whole to the power of n into 1 by 1 plus 1 by n whole to the power of 1. So this will be equal to, this limit is e, and this limit is 1 by 1 plus 0, which is equal to e. This is not equal to 0. So by limit comparison test, by limit comparison test, both converge or diverge together. So our series also summation un is divergent, right? So I'm removing this. So you can write the next step. So that's all in this class. We are left with some more examples from 8 to 17. We'll do in the next class, and we'll finish this limit comparison test problems. Thank you.